Hello everyone, it's Mr. Shea and I can't believe it's finals. So what I'm going to do is in this video, I am going to help you prepare for your final exam tomorrow. The final exam is somewhat cumulative with us covering standard 4 equivalent equations, standards 5 and 6, which covers graphing linear equations. So what we're going to do first is we're going to take a look at this problem here. In standard form, we worked on solving equations. So what we're going to do is we want to solve this equation for x. Now, what I recommend doing is we don't want the parentheses. So what we're going to do is we are going to distribute the -7 through. All right, so what I'm going to do is rewrite the left side because we did nothing to it. The 8 can stay the same. Now, essentially, when I multiply, when I distribute, we have -7 multiplied by 2x plus that same -7 multiplied by -5. And what I want to do is I want to simplify that. I'm going to say 8 minus 7 times 2 is 14x. And we have a negative times a negative is a positive. We have plus 35. All right, now the next step is maybe we could combine like terms. So what I'm going to do is I'm going to combine like terms. 8 plus 35 is equal to 43. And I still have that minus 14x. Now we want to get the x all by itself, so what I want to do is maybe move this constant term to the left, and in order to do that, I need to subtract 43 from both sides to make this go away. Okay, 7 plus 7, that's going to be 14. Okay, 14 equals, we have negative 14x. And it looks like we have one more step, and what I want to do is I'm going to divide by negative 14 on both sides. And I'm going to get -1 equals x, or x equals -1. Now, if you're someone that is worried that you're not sure this answer is right or wrong, worried that this answer is right or not, what you can do is you can actually plug this back into the equation to see if it is true. Now, if we plug this value inside, it will make the equation true. Let's take a look. We have 57 equals, we have 8 minus 7 multiplied by 2 times, okay, x is -1 minus 5. So if you notice, we're plugging -1 into the equation for x. And what we want to do is simplify this. We want to reduce it and see if both sides are equal. Okay, we have 8 minus 7 multiplied by, let's simplify this first. 2 times -1 is -2 minus 5. Now what I could do is I could just simplify that here again. All right, we have 57 equals 8 minus 7 times, well, this is -7. -7 times -7 is positive, so I have 57 equals 8 plus 49. And 8 plus 49 is 57, so look, both sides are equal. Let's take a look at the next one. Okay, so on your final, you are verbatim going to get two equations just like this. So you do need to know how to solve with multiple steps. This one's very similar. There's only one more step. Looks like we have x is on the left now and x is on the right. So let's do this. Let's use the same steps we used in the last one to solve. I want to distribute this 3 through. So I have -15 plus 12x is equal to 9 plus, now let's do this in our heads, 3 multiplied by 6 is 18x plus, okay, 3 multiplied by 4 is 12. Okay, next step is I want to combine like terms again. We can add these together to simplify. We have negative 15 plus 12x is equal to, all right, 9 plus 12, that's equal to 21 plus 18x stays the same. All right, we want to get the x's on one side. We want to solve. I'm going to move the x's to the right. I see there are less x's on the left. Let's move them to the right. I want to subtract 12x to move it to the right. If I rewrite, I have negative 15 equals 21. 18 minus 12 is 6. I still have 6 x's. It looks like from here we have 2 more steps. I want to subtract 21. I want to move the constants, the numbers to the left. The constants are the numbers without the variables. Okay, I have negative 36 equals 6x. And now the last step is just dividing. We're going to divide by 6 because 6 times a number is equal to negative 36. If we do the inverse of multiplication, division, we can isolate x. Negative 6 equals x, or we can say x equals negative 6. Again, if you want to see if this is correct or not, you can always take your solution. You can put it back into the equation to do a check step. All right, so that is equivalent equations in a nutshell. Now what we're going to do is we want to look at standards 5 and 6, graphing linear equations. Let's take a look. In this section, we need to know some key vocabulary. The first vocab term we need to know is x-intercept. Intercept kind of sounds like intersect. An intercept is where we intersect an axis. So maybe the x-axis, y-axis. The slope is a little different. We'll look at that in a little bit. M is slope. When we say slope, we can use the letter M. Not sure why we use M for slope, as slope is a pretty short word. Maybe x-intercept and y-intercept could be a little better for it. But anyways, we use M for slope. X-intercept, y-intercept are also vocab we need to know. Let's do this. Let's look at the graph and see if we can locate these points. Let's first find the x-intercept. The x-intercept I'm going to color code in green. The x-intercept has a coordinate value of 2, 0. When x is 2, y is equal to 0. This is the x-intercept. The y-intercept is where we cross the y-axis. The y-intercept has a coordinate value of 0, 3. When x is 0, y is 3. Now the slope is how do we get from the point on the left, the blue, to the green? Okay, well, if you think about movement, we have to go, maybe think of city blocks. We have to go down 3 city blocks, so maybe south, and then to the right by 2 city blocks. And that is how we get from one point to another. You could do that over here, one point to the next. All right, the slope is telling us the direction in which the line moves, how we get from one point to another. Let's do this. Let's take what we just found and let's provide the answers. Okay, well, we see that the x-intercept is 2, 0. The y-intercept is 0, 3. And the slope, we see that it's going down from left to right, so we want to write negative 3 over 2. The slope is the change in y divided by the change in x. Or, as we talked about before, we can say rise over run. What is the change in y? The rise divided by the change in run. Okay, so maybe we now have an equation and we want to maybe graph the line this time around. What we need to first understand is that all equations in this form have a pattern. And that pattern is this. m is the slope. The slope, again, is change of y over change of x, as we did in the previous problem. Now, there actually is a letter for y-intercept. We say b. The b is the y-intercept. Sometimes people call these the start and the change. When we have a linear relationship, we start at a value and we change by a specific slope value. Okay, so here clearly we see that our slope is 4, and our start, we're starting with -3. Just one thing to consider, 4 is the same as saying 4 over 1. We always like fractions with slope. Okay, so let's do this. We want to graph this line. We want to start at -3. We're going to start here. And our slope is up 4. I'll put over here, our slope is 4 over 1. We're going to go up 4 because it's positive and to the right by 1. All right, let's take a look. We're going to go up 4. All right, so I'm going to go up 1, 2, 3, 4. 1, 2, 3, 4. And to the right by 1. Here is my next point. You can go up 4 again if you'd like. 1, 2, 3, 4, and right by 1. Here's another point on the graph. You can go backwards. You only need 2 points, however. Now, what I'm going to do is I'm going to use a ruler, and I want to make a line through these points to demonstrate the linear relationship. Here is our line, and I want to make arrows on both ends indicating that we are going infinitely in both directions. Okay. Awesome, let's go to the next page. So standards 4, 5, and 6 covered. You will see problems exactly like this on the final. Equations. Standard 7 is looking at interpreting and creating graphs of functions, focusing on linear equations or finals. Okay. Standard 7 is interpreting and creating graphs of functions, and functions that are including linear relationships. So let's take a look. We want to answer these questions about this graph. Now I see this graph and I see different segments. So maybe the problem is going to ask us about different parts. Let's take a look at the first question. It says, how many minutes does it take to fill the tank to 75 gallons? Okay, so I see 75 gallons. I'm assuming this is going to be the Y value. Let's take a look. All right, I see gallons. We want to get to 75. Okay, well, if we're starting at 0, I see we start here and we go upwards. Okay, after, let's see, it's what, 5 minutes? 5, 50? 5 minutes, we have 50 gallons. It looks like we keep going. We look at this point here. Okay, we look at this point and take a look. 10, 75. The X value is the minutes. The Y value is the gallons. This says when X is 10, when the time is 10 minutes, the Y value is 75 gallons. So our answer to the question is going to be 10 minutes. Always put the units on. Okay, let's take a look at question B. It says, what is happening to the water between minute 20 and 25? Okay, so I want to take a look between minute 20 and 25. Okay, so minute 20 is here. 25 is like somewhere in the middle here. Looks like we're starting here and we're going towards minute 25, right about here. Okay, well, clearly we start at minute 20 and the graph is higher up. As we increase in time, it looks like the value of the gallons is going down. So what we could say is, if we were to describe what's happening, the tank is losing water. It's not increasing in gallons, it's decreasing. Okay, question C. The very last point on the graph does not have a coordinate. Label the coordinate. Okay, so what we want to do is we want to label this coordinate. We're probably going to have to use information about the graph to find it. Let's see. Okay, so we want to label this coordinate here. Now, what I know about points is that points always have an x value and a y value. Here's what I'm going to do. I'm going to use my ruler again. And what I want to do is I want to find the y value and the x value. If I draw a horizontal line to the y-axis, I'm going to find the y value. And if I draw a vertical line, I'm going to find the x value. So I want to use a straight line so I'm accurate. Okay, let's take a look. All right, well, it appears that the x value is 60 and the y value is 100. So if we were to label this, we're going to say when x is 60, y is 100. We want to label. Okay, last one. It says, what is the rate, slope, at which the tank is being filled between minute 40 and 45? Okay, between minute 40 and 45. Okay, so we want to find the slope, the rise over run. 40 and 45, let's take a look. Okay, well, 40 is here. 45 is like in the middle. Okay, so we start here, we're going up. Okay, so we want to find the slope of this segment of the graph in yellow. So here's what I'm going to do. I can create a slope triangle. We have learned that slope triangles can be used to find rates of change. We want to find the slope. The slope, or the rate, is the change of y divided by the change of x. So let's find the change of y. Let's find the vertical change. The vertical change is from here to here. You can even look at the points. We go from 25 to 50. Okay, that's a distance of 25. So we have a distance of 25. For the y change, let's find the x change. The x goes from 40 to 45 because we know the seconds. Well, that's just a change of 5. Now, if we were to look at this slope triangle, well, slope, we know, is the change of y over the change of x. That's just 25 divided by 5, which is 5, or 5 over 1. The slope is 5, or 5 over 1. So it says, what is the rate, slope, at which the tank is being filled? We can say 5. Now, 5 gallons is the unit. We're going to say 5 gallons per minute. We want to use the units. So we have 5 gallons per minute. Okay, let's take a look at the next problem, which is similar, but we want to actually create the graph. All right, the next problem says the following. We want to basically create a situation. I will read. It says, at the senior boat dance, the staff only have 60 minutes to load all students onto the boat. So this actually happened. There was a senior boat dance, which is kind of cool. When they start loading students at time 0, there are 0 students on the boat. Makes sense. Over the next 20 minutes, they load 200 students on the boat. There's now a crowd getting onto the boat, so they pause loading for the next 5 minutes. In the next 30 minutes, another 150 students board the boat. In the last 5 minutes, the last 25 students get on the boat. So here's what we want to do. We want to create a story. Now, if you have colored pencils or highlighters or markers, you might want to use those in problems like this to organize your work. Okay. We only have 60 minutes to move the kids onto the boat. Probably going to be our X restriction. It says when they start loading, there are 0 students on the boat when time is 0. So here's what I'm going to do. I'm going to make a point. Our first point is here. We have the point 0, 0 because when the time is 0, we have no students on the boat. When the time is 0 minutes, we have no students on the boat. All right, first part done. The next part. It reads, over the next 20 minutes, they load 200 students on the boat. Okay. Over the next 20 minutes, they load 200 students on the boat. Okay, so just remember, we're at time 0. We want to go the next 20 minutes. So at 20 minutes, we will have 200 students on the boat. This is representing a point on the function. And what we want to do again is make sure, let's use a ruler. And this is going to be our first leg or first piece of our function. All right, first part done. There's now a crowd getting onto the boat, so they pause. They pause loading the boat. They pause loading for the next 5 minutes. Okay, well, if they pause, the number of students doesn't change. Let's look at the graph. Okay, if it pauses for 5 minutes, okay, well, we're just going to go 5 minutes. We're going to pause. We're going to have the same amount of students for the next 5 minutes, okay? Here's our next leg. We're going to stay the same amount of students. We still have 200 on the boat over the next 5 minutes. Okay, in the next 30 minutes, another 150 students board the boat. Okay, so 30 minutes, another 150. Okay. So 30 minutes, well, we start at 25 plus 30 is 55, right? We're going to go to here now. 25 plus 30 is 55. And 200 plus, we're adding 150 students. That's going to get us to 350. Okay, so we want to go from 200, we're going to add 150, go to 350. Okay, so we are at 55 minutes, and we will have 350 students on the boat. Just remember, we always want to use a ruler to make our work nice and neat. We want to be accurate. Okay, and the last part says in the last 5 minutes, let's see, it says the last 25 students get on the boat. Okay, well, next 5 minutes, let's take a look. So we go from 55 to 60. And the last, it says 25 students. Okay, so we want to add 25 students from 350. Well, here's 25, right? We're just going to jump from here to here. We're going to go up 25. Okay, and the last piece looks like this. All right. So when we do this in your final, you want to be very accurate in your graphing. Everyone, let's take a look at the questions. The first question says, in the first 20 minutes, at what rate are they loading the students onto the boat? Okay, the first 20 minutes, that is the blue section. We actually know this. It's 200 students per 20 minutes. It's 200 is the change in y over 20. So we are given this in the problem. We want to basically simplify. We have 200 over 20 minutes. Okay, well, 200 divided by 20, eliminate 1, 0 for the 10. 20 divided by 2 is 10. It's going to be 10 students per, we have minute. Okay, so our answer is going to be 10 students per minute. It is our rate. A rate is a slope, rise over run. 10 students per 1 minute. Question C says, how many students are on the boat after 60 minutes? Let's take a look. After 60 minutes. Well, 60 minutes is the point at the very end, okay? If we draw lines vertical up to the point, okay, here's our point, and we want to draw horizontal lines over to the y value. We clearly see our point is at 60, comma, this is 375. There are 375 students on the boat. So we're going to say 375 students. Okay, last question. In the last 5 minutes, what rate are the students loading onto the boat? Okay, in the last 5 minutes, we want to find the last piece right here. Okay, here's the last 5 minutes. Last 5 minutes is this segment that is right here. Okay, so if we look here, we could make a slope triangle. Let me use a different color. Use orange. Good San Mateo colors. All right, we want to find this rate. Now we go up 1 block, which is 25 on the y-axis. We go over 5 on the x-axis. Okay, so our slope is change of y over change of x. We have 25 over 5, which is equal to 5. We say 5 students per minute. So I'm going to go here and I'm going to say 5 students, I want the units, per minute, per 1 minute. All right. Standard 8 is exponential functions. Standard 9 is quadratic functions. Let's take a look at exponential functions. An exponential function is a rule which represents repeated multiplication. Let's take a look at this relationship here. Now, when we have functions, we always talk about an x and a y. We have an x value here, and we have the function of x, or the y value. Now, when x is equal to -1, our respective y value is 2. When our x value is 0, the y value is 8. When x is 1, y is 32. When x is 2, y is 128. As you notice, the y values get really, really, really big. We want to identify the equation for this exponential function. So here's what we're going to do. all exponentials follow this form, where these letters represent the starting value. So A is the start value, or you can say the y-intercept. And the B is the multiplier, because we're talking about exponentials, repeated multiplication. Some people say factor. I like multiply because we're multiplying. Let's take a look. The easiest way to find the y-intercept is this. We want to see, where is x 0? Because when we have a y-intercept, it is where x is equal to 0 on a graph. Now look, we know that our y-intercept is 8. We start at 8, and now we want to find what are we multiplying by to get the next value. All right, well, I know 8 times 4 is 32. Let's see if this rule holds. Okay, 32 times 4 is 128, perfect. And look, you could even look at this change, look, times multiplied by 4. I think we're ready to write our equation. Our equation is going to be, we want to use f of x because it's a function. F of x is equal to, the y value is equal to, the a value is 8. So we're going to say 8 multiplied by, our multiplier is 4, and we need to raise it to the power of x. This is our exponential function. Let's do the same thing, but let's have a graph this time. Let's see if we can find the function using a graph. Okay, so again, we want to write an equation in this form. A is going to be the y-intercept or the start. Let's find this. Here is our y-intercept. The y-intercept is 0, 4. Our a value is equal to 4. Now what we want to do is we want to find the multiplier. Now we need to identify more points. For example, these are different points on our exponential. And as you notice, the y value here is 8. The y value here is 4. The y value here is 2. The y value here is 1. If we jump from 8 down to 4, we're dividing by 2. If we jump from, let me just get this out of the way. If we jump from 4 and we go to the next point, well, we go from 4 to 2 for y. Again, we're dividing by 2. If we jump from 2 to 1 in y value, we're dividing by 2 again. The way we divide by 2 is by multiplying by 1/2. So here's what we got. The a value, the start, is equal to 4. Now your multiplier is going to be 1/2, because we need to multiply by 1/2 to divide by 2. Our equation is going to be y is equal to, we start at 4. Now, I like to use parentheses when I have fractions. 4 times 1/2 to the power of x. This is our exponential. The start is 4. The multiplier is 1/2. Okay, let's go to the next standard. The next standard is going to be quadratics, a little bit different. Quadratics, instead of looking like lines, which look like this, is what we studied in the first part. Lines look completely linear. Exponentials go up, 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 or down, down, down. Quadratics look like this. They look like U's. They look like U's. So this is what we're gonna do. We're gonna first have to graph something that looks like a U. So what we're gonna do is we're gonna use a table. The table is going to help us find points on the graph, and that is going to help us make points so we can accurately and neatly graph the quadratic. Let's do this. This is saying we want to put the x values inside of the function we are going to evaluate using this table. So here's what I'm going to do. I'm going to neatly evaluate for each of these x values. I'm going to say the function of -2 equals. Okay, wherever we see an x, we want to put in -2. Okay, we have 2 times -2 squared minus 3. Okay, -2 squared is 4, so we have 2 multiplied by 4 minus 3. Okay, now 2 multiplied by 4 is equal to 8. 8 minus 3 is 5. Okay, let's find that point on the graph and graph it. We have the point -2, comma 5. -2, comma 5, well, -2 is here, 5 is here, -2, comma 5 is right here. So what we want to do is we want to find 4 more points and graph this line. Let's try the next one. We have f of -1. Again, we're going to put it inside where x is. We have 2 times -1 squared minus 3. This is called the input. The input value is -1. We want to find the output. If we put 1 in, what do we get out? All right. 2 times 1 is equal to 2. 2 minus 3 is -1. We have the point. We plug in -1 and we get -1. All right. Let's graph this point. We have -1, -1 is right here. Let's try the next one. We want to plug in 0. We have f of 0 equals. Okay, we have 2 times 0 squared minus 3. Well, this one's easy. Anything times 0 is 0. We have 0 minus 3, and that equals -3. Our point is 0, -3. Okay, 0, -3 is right here. Let's try the next one. We have function of 1. Let's plug in 1. We have 2 times 1 squared minus 3 equals, okay, 1 squared is 1. 2 times 1 is 2 minus 3 equals -1 again. All right, now when we see this -1 again, we have the point 1, -1. It looks like it's going to start bending upwards again. Our parabola looks like this. It goes down, it hits this point here, and then it's going to go back up again. We know the value for 2 is going to be 5 because parabolas are symmetrical. That was bad. Try that again. Okay, so we're going to do this. We're going to graph our parabola just like this. Okay, now besides graphing a parabola, we also have to look at tables and determine what does each function represent. It could be a line, it could be a linear function, it could be an exponential function, or it could be quadratic. The difference is this. When we have a linear function, we have repeated addition or subtraction. When we have exponential, we have repeated multiplication. In quadratic, doesn't have either of those, but what it does have is it has a common second change, and I'll show you what that means in a second. So let's do this. Let's see if we can notice the pattern. All right, so when I take a look at these values, the x is increasing by 1. Let's take a look at the y values, the f of x values. I notice that my phone's barking. All right, I notice that we are adding by 4 each time. We're adding by 4 here, we're adding by 4 here, and we're adding by 4 here. When we have repeated addition, that's the same each time, this is a linear function. This is linear. We have repeated addition, the same change every time. Let's try the next one. Okay, this one's a little different. We notice that from 4 to 12, this is multiplying by 3. 12 to 36, this is multiplying by 3. Multiplying by 3. Just like we did before when we have repeated multiplication, this is exponential. This is an exponential function. Okay, the next one, this one's a little different. Now we're not multiplying by anything, we're definitely adding 2 times. There's not a clear number that's obvious for each. It looks like we're adding by 1, then we're adding by 3, and then we're adding by 5. Strange. Now, if you see something like this, what I want you to notice is that when we increase by 1, increase by 3, and then increase by 5, it's neither linear nor exponential. So it can't be those two. So you could just do this. We know it can't be these two. It has to be quadratic. The reason why it's quadratic is because the second change is the same. We're adding by 2 each time we increase in a change. So this is quadratic for that very reason. This is what we're going to say is quadratic. It's not linear. It's not exponential. It has to be quadratic. Okay, let's take a look at the last one. Okay, well, clearly I see we are multiplying again. We're multiplying by 5 here. Okay, 10 times 5 is 50. 50 multiplied by 5. Okay, repeated multiplication. I know that is exponential. So my best advice for you is if you can find that it's not linear or exponential, it has to be quadratic. If we're adding by a constant change each time, the same change adding, it's linear. If we are multiplying by the same thing each time, like this one or this one, it's exponential. This one here, it's not adding by the same thing, but it has the same second change. It's not linear or exponential, it's quadratic. Standard 12, factoring standard form of a quadratic graph. Okay, this part is arguably going to be the most difficult because a lot of us struggled with quadratics and factoring them. So here's what we're going to do. We are going to practice so that you can be a little more successful than our standard 12 assessment. Okay, everyone, here's what we're going to do first. We want to factor and find the solutions. Now, first what we want to do is we want to factor this. A factor is when we multiply 2 things together to get a product. Now, we want to express this equation, this expression like this. We want something times something equals 0. So here's what we're going to do. We are going to first use these 2 numbers here. We want to use an area model. We're going to factor by using that area model. And what this helps us do is find the 2 expressions that multiply to create this trinomial. What we know is that 6x squared and -4 go in these 2 sections. But the question is, what do we put in this box here and this box here? Now what we want to do is we want to create 5x somehow. The way we're going to create 5x is by, we want to multiply 6 and negative 4. We want to take the factors of 6 times negative 4 at negative 24. And the sum has to be 5. So let's take a look. We have 1 and 24, the factors. We have 2 and 12, 3 and 8, 4 and 6. So what we got to do is think about the factors. We have to put factors inside these two boxes that we can use with a common factor and factor this trinomial. So I noticed that if we are to get 5, one of them has to be negative, so I'm going to make 3 negative. We're going to have negative 3x's and 8x's because the sum, again, is going to be 5x's if we add them. Okay? Now we can factor. What I'm going to do is I'm going to pull out the GCF of each row and column. The GCF of 6x squared and negative 3x is 3x. If I take out a 3x here, this would have to be 2x. 2x is the GCF of 6x squared and 8x. If this is 2x, well, this would have to be 4 to create 8x. And this would have to be negative 1 to create negative 3x. I think we have our two factors. We have 2x minus 1 and 3x plus 4. Since we have our factors, we can now solve our equation. Now we have it in a better form we want to solve. Now what we know from the zero product property is this. We can have 2x minus 1 has to be 0, or 3x plus 4 has to be 0. Let's solve the first equation. Okay, 2x equals 1. We can divide by 2. Okay, our first solution is x equals 1/2. That's our first solution. Let's find the second one. We want to move the 4 over by subtracting. We have 3x equals negative 4. Okay, now we can divide by 3 to isolate the x. X is negative 4 over 3. Those are our two solutions. Okay. So to factor a trinomial and solve, we want to use those steps there. Kind of a lot, definitely not easy. The more you do it, the more practice you get, the better you become. Now let's try this. This one we're not going to solve using that method. We're going to actually solve using just steps of isolating. So here's what I want to do first. I want to get this x squared term by itself. So this is the easy way to do this. We're going to add by 9 on both sides. Okay, now we do want to isolate the x squared term, so let's do this. Let's divide by 100 on both sides. Okay, so here's what we get. We get x squared equals 9 over 100. Think about what this means. X squared. X squared means x multiplied by itself equals 9 over 100. Now, something times something equals 9 over 100. Well, the answer is a fraction, so I'm thinking we must be multiplying two fractions together. So what I'm thinking is this. A fraction multiplied by a fraction needs to equal 9 over 100. Think about it this way. A fraction a over b multiplied by fraction a over b has to be 9 over 100. In other terms, what you could say is this. A multiplied by a has to be 9, and b multiplied by b has to be 100. Okay, well, if a times a equals 9, a squared equals 9, well, a could be plus or minus 3. If b times b equals 100, well, b squared equals 100. We know that b could be plus or minus 10. 3 times 3 is 9, or negative 3 times negative 3 is 9. Likewise, 10 times 10 is 100, or negative 10 times negative 10 equals 100. There are two solutions. The solutions are these. Our fraction could be 3 over 10, or it could be negative 3 over 10. There are two solutions. If we have 3 over 10 and we square it, well, 3 squared is equal to 9, and 10 squared is 100. If we have negative 3 over 10 squared, well, a negative times a negative is a positive. It's the same thing. Perfect. Everyone, let's go to this next problem here before we do part C. Let's factor using the GCF and solve. Okay, so we want to factor the GCF. We want to factor out the greatest common factor and solve. Let's do this. Let's look at these numbers here. Now, one way you can do it to organize is like this. We have 15x squared minus 24x, and the way we can do it is like this. I notice we can divide both the expressions by 3. Okay, 15 divided by 3 is 5. 24 divided by 3 is 8. Okay, now I notice they both have an x in common. Let's factor out an x. 5x minus, okay, take the x away. Now this is what this is saying. It's saying our greatest common factor, the factor for both terms that we can take out of both, the largest one is 3x. Our quotient, we get 5x minus 8. Okay, so what we're saying is this. This expression is the same as saying 3x multiplied by 5x minus 8, and that equals to 0. And now we want to solve. But this is actually easy because look, we have this factor multiplied by this factor. We have two factors multiplied equals 0. Well, I know this. I know 3x could be 0. I also know that 5x minus 8, that could be 0. All we have to do is solve. Okay, inverse of multiplication is division. Okay, here's our first solution. X equals 0. The next solution looks like it's not a whole number. It's not an integer. An integer is a whole number. Let's divide by 5. Our second solution is 5 over 8. And there are our two solutions. So GCF is when we pull out a number or variable set that is common in both. By creating two factors, having two factors being multiplied, or the product of two factors gives us 0, we can create two equations and solve. Okay, so here's what we're going to do. This is probably the hardest problem on this page. We want to take a function and basically solve some problems involving context. So let's take a look. It says the height of an object in meters launched straight up from a cannon is modeled by the function. All right, it says h of t, h meaning height. The height of the cannonball off the ground is given by negative 6t squared plus 14t plus 40, where t represents time in seconds after the launch. Now, I know what you're thinking. You're like, what the heck does this mean? Okay, so this is just a function. This is saying when we have a certain time, if we put that time t, a number, maybe that number is 5. Maybe that number is 6. Maybe it's 1. after a certain amount of time, we're going to have this height off the ground if we evaluate. So this is just telling us, maybe it looks something like this. Maybe this is our graph. Maybe it's a parabola, it goes up, it goes down. Maybe our graph looks like that. But we have a relationship. We want to figure out some different parts about the flight of this cannonball. So let's do this. Let's use the questions or the information in them to solve. It says, after how many seconds does the object hit the ground? Okay, well, when something hits the ground, the height of the cannonball must be 0. So here's what I'm going to do. If the height is 0, then we're going to make our function equal to 0. We have negative 6t squared plus 14t plus 40. That is equal to 0. Now, before we start solving, I'm actually going to factor something out. Let's factor out the GCF, because I think that it's going to make our factoring using the area model a little easier. I'm noticing that we can divide all of these by 2. I'm going to factor out a negative 2. Here's why. If I factor out a negative 2, negative 6 divided by negative 2 is 3. We have 3t squared. 14 divided by negative 2 is going to be negative 7t. And 40 divided by negative 2 is going to be negative 20. I like dividing by a negative just so that maybe I get rid of it for one of the terms. It doesn't really matter, it's just preference. For this one, it may not even matter. You could just do 2 if you wanted. So for example, if I try that again, for people that don't like factoring out a negative, let's just do a positive. Let's factor out a 2. Okay, we have negative 3t squared plus 14 divided by 2 is 7t. 40 divided by 2 is plus 20. Okay. Now what we need to do next is we want to factor this quadratic. Here's what we know. We can put these terms in the box right now. So here's what I want to do. Similar to the top of the page, I want to put these values in this area model box right now. I'm going to put, let's see, we have negative 3t squared and 20. Now what we want to do is we want to create 7t between these two squares. The way we're going to achieve that is that we're going to use negative 3 and 20. We're going to multiply them to create negative 60. The factors of these two numbers must help us create the red numbers. So here's what we're going to do. We're going to list all the factors of 60. We have 1 and 60, 2 and 30, 3 and 20, 4, 15, 5 and 12, 6 and 10. Okay, so I look at these and we want to create 7t. We want to create this 7t right here. All right, so I'm thinking we're going to use 5 and 12. I want positive 12t and negative 5t because the sum is 7t. All right, so now we want to factor. I can factor out a negative t from both of these two terms vertically. If this is negative t, this term has to be 3t. Over here, if it's 3t, this must be 4. And right here, we must have 5. I have my two factors, 3t plus 5 and negative t plus 4. Okay, so we're close to solving. Let's write these down. We have negative t plus 4 multiplied by 3t plus 5. This has to equal 0, just like we did in part A. Now let's solve. We have negative t plus 4. This could be 0, or 3t plus 5 equals 0. Okay. Now what we can do is we can subtract by 4. Okay, we can divide by negative 1 because there's a negative 1 in front. Okay, t equals 4 seconds. Now, if we solve the second equation, what we notice is that we actually get a negative time. If we solve, we actually get t equals negative 5 over 3. We actually don't use the solution because it's negative. It makes no sense for the problem. So our solution is just going to be the time is 4 seconds. It takes 4 seconds for the cannonball to hit the ground. It goes up and it comes down and it hits the ground. Okay, now let's try the next one. This one's a little different. It says, at what 2 times does the object reach a height of 44 meters off the ground? So here's what we want to do. We're going to start setting up the same type of equation. We have h of t equals negative 6t squared plus 14t plus 40. Instead of equaling 0, it's going to equal 44. This is the same type of problem, but all we got to do is just make it equal to 0 first. There's no real change. So here's what we're going to do. We're going to subtract by 44 on both sides. Okay. And now look, now we have negative 6t squared plus 14t. Now we have minus 4 equals 0. So here's what we want to do. We want to solve this. Again, what we might want to do is factor out a GCF. I'm going to look through, and what I'm going to do is I'm going to factor out a negative 2. I'm going to factor out a negative 2, and what we're going to get is a trinomial left over. Let's see, the quotient will be, we factor out a negative 2, we have 3t squared, negative 7t, and then we have factor out a negative 2, we have plus 2. Okay, we want to solve this equation. Now, if we divide by negative 2 on both sides, notice how the right doesn't change. It's just 3t squared minus 7t plus 2 equals 0 still. So when we solve this equation, you actually don't need to even worry about this negative 2. It actually has no use. Okay, let's factor. We want to use an area model, so I'm going to make an area model right here. And we know that these terms, right, these 2 terms here and here, we can actually put them inside. Okay, so I'm going to put 3t squared and 2 inside. We know we have to create this negative 7t somehow. And what we're going to do is we are going to use the factors of 3 times 2. 3 times 2 is 6. This is actually kind of easy because there's only 2 pairs of factors. What we're going to do is we're going to use 1 and 6. We're going to make both negative. So we're going to have negative t, negative 1t, and negative 6t. Those add to be negative 7, but multiply to be 6. And now we want to factor. So let's do this. Let's factor. If I factor, I'm going to get, let's see, I can take a 3t here, and this would be t. Okay, if I have 3t, this over here would be negative 2, and this would be negative 1. All right, here's our first factor right here. We have t minus 2 times 3t minus 1. I'm going to take these over here. And what we're going to do is we're going to solve. So we have 2 factors multiplied are equal to 0, 3t minus 1, and t minus 2. Okay, so we have 3t minus 1 and t minus 2. Okay, well again, we can create 2 equations. 3t minus 1 equals 0. T minus 2 equals 0. This one's super easy to solve. We have 1 step. Okay, after 2 seconds, the height is 44 meters. Now, to solve the second one, we need 2 steps. Okay, we add 1 and then divide by 3. Here's the second solution. After 1/3 second, the cannon is 44 meters off the ground. So again, these are in seconds. I might want to put the unit next to it. Seconds. Everyone, we're almost there. And standard 13, the quadratic formula. So what we're going to do is we're going to go over the solutions to this review packet. Okay, the last problem is going to be quadratic formula. Before we start, please sing the song. In your head, that is. But I'm going to sing it. Okay, so I'm going to embarrass myself again. Okay, so my teacher always told us it's kind of like Pop Goes the Weasel, and we go x. So it goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so someone's going to use that as blackmail later. All right, so we got the quadratic formula, x equals negative b. So we're going to use this. Now we have different values that represent parts of an equation. We have b, we have a, and we have c. So what do those mean? Let's take a look. Let's use this equation below. The a value is the coefficient of the quadratic term. The x squared has a coefficient of 2. A is equal to 2. The b is the coefficient of the linear term, right, x. And the c is the constant term. So what we see is that the values are a equals 2, b -5, and c is -4. We're going to put these values inside and solve. And what that does is it finds our solutions. We don't have to factor and solve the equations. We can actually just use this. This is what we're doing. If we want to see where the cannonball hits the ground, we can actually use these values here. So let's do this. Let's put it inside. Okay, so we're going to say x equals negative b. So we have negative b is -5. So I'm going to put -5. X equals negative b. B is -5. Plus or minus the square root of b squared, -5 squared, minus 4 times a times c. Okay, getting a little cramped over here, so I'm going to erase some parts of this. Okay, I can look at the top if I need. All right, let me zoom in. Okay, so we have 4 times a times c. A is 2, c is -4, right? Because we have a, b, and c. And it's all over 2 times a is 2. Perfect. Okay, so x equals -b plus or minus this. Okay, so we have 5 plus or minus the square root of -5 squared is 25. Minus 4 is c. Okay, so negative. This is positive. 4 times 2 is 8. 8 times 4 is 32. We have 25 plus 32 divided by 2 times 2 is 4. Okay, we're getting there. We want to simplify this and see what we get. Okay, we have x equals -b. Okay, but that's just 5. Plus or minus the square root of b squared minus 4ac. Simplify this, right? That's 57. Okay, 57. All over 2a is just 4. Okay, we get to this part, everyone, and look, we have two solutions. We could have the positive, right? We could be looking at the positive version, meaning we could be looking at 5 plus square root of 57 divided by 4. Or we could be looking at the negative, right? The minus, the subtracting. We could do 5 minus square root of 57 divided by 4. Okay, now what you're going to do is you are going to evaluate these with your calculator. These are not rational, they're irrational. The reason being is because square root of 57 is not a perfect square. If you have a square where the area is 57, there's no x value where x squared is equal to 57. There's no value x where this value of x is an integer, right? It's an irrational number. The decimal goes on and on and on and on and on. So we want to find this on our calculator. We're going to enter it. Now, I don't have a calculator in front of me, but what you're going to do is you're going to enter it in. You're going to find your first solution, and you're going to find your second solution. That's how you solve. Everyone, I thank you for coming. I wish you the best of luck. Tomorrow, what we're going to do is have 30 minutes to review before we start. Some of you may not have watched this video. I'm going to make you watch it because it's going to help. You're going to sift through and maybe go over the parts that you don't know. And that's it. Everyone get plenty of sleep, eat a good breakfast, and I'll see you tomorrow at 10:45. Good luck studying.